All right, you guys. We are playing around with the definition of a polynomial function. Polynomial functions are really nice, friendly functions. They're everywhere continuous. They're nice and smooth. There's no breaks in a polynomial function. There's no cusps, which are really sharp points. And if there's no breaks, then there can't be any asymptotes. Okay, they're just nice and smooth. They start and they keep going, and like waves, things like that. So we've already done some polynomial functions that you know of. Maybe you don't know they're called polynomial functions yet, but you will. Okay? So the definition of a polynomial function says that if you let n be any non-negative integer, and you let a sub n, and I'm going to say this, what this is right here, you're going to hear me saying this, it's a sub n. Got that? So when I say this kind of fast, sometimes students think I'm saying ace of n. And can you understand that this would mean a sub n? Why is it sub? Anybody?
It's a subscript.
It's a subscript. Okay, so we say a sub n, because the n is a subscript, as opposed to a superscript like an exponent. It's a subscript. It's not ace of n. That would have nothing to do with what we're talking about, true? Okay, so this has nothing to do with the context of what we're dealing with. This is what I'm saying when I say a sub n. And I'll try to say it as clearly as I can, as often as I can, but I do kind of talk fast. You know that, right? No? Okay. This is a sub n minus 1, a sub n minus 2, a sub n minus 3, a sub n minus 4, all the way down to a sub 2, a sub 1, a sub 0. So n can be any non-negative integer. If n were like 10, this would be a sub 10. This would be a sub
10 minus 1.
Which is?
9.
A sub 9, a sub 8, and it keeps going all the way down. Remember, you guys just got done doing synthetic and long division, and you know how when we're doing our long division, we had to start with the highest exponent and have every exponent from there on down in order, and sometimes we needed fillers. So this is kind of the same idea. They're just giving you every exponent from there on. Well, you'll see it. I'm coming up to it right here. You'll see it in just a second. So the function f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2. And I could keep going and do minus 3s and minus 4s, and I know it looks a little complicated right now, but it's really not. I'll give you an example in just a sec. Plus plus a sub 2 x squared plus a sub 1 x to the first plus a sub 0 x to the 0. And if I have x to the 0, that equals 1, so I don't have to write that. As a matter of fact, I don't even need to write that 1 up here on this exponent either, do I? No. Okay. So, take it, leave it, yes or no? Now, you've already studied a bunch of functions that are polynomial functions. As a matter of fact, I think probably the first function you ever studied was the one that just has two things down here. What does this look like to you? This would look like f of x equals, if none of this existed, only f of x equals, it would look like something times x, kind of like, I don't know, 3x plus 4. What's this?
Linear function.
It's a what?
Linear function.
It's a linear function. It's a straight line. Okay. So linear functions, straight lines, are definitely one type of polynomial function. And that just the last two terms. It's just something times x plus something on the end. This is like y equals mx plus b. Okay, so you've already studied linear functions, and you know they're nice and smooth, right? Lines are smooth. All right, so that one's done. What if instead of starting like that, what if I took the next term and I grabbed the square part and made up a number for this? Give me a number here. 5. So what if all of this was gone and this was just f of x equals blah, blah, blah? What kind of a function is this?
Quadratic.
It's a quadratic function, okay? And you already know what quadratic functions look like, right? What do they look like? What's the shape? Parabolas, what letter?
U.
Good, okay, I see your hands doing this thing. Okay, they're U-shaped, they're nice and smooth, right? No sharp points, no gaps, no asymptotes, nothing funky happening, really nice. Okay, what happens if maybe I grab the next one, what would be this one here?
X to the third.
Yeah, something x to the third, right, x cubed. Okay, and I can put a number here or not put a number here, or I put like -2 just to mix it up a little bit. What kind of a function do we call this?
Cubic.
It's a cubic function, okay, so you start studying linear functions, you get into quadratics, and then you get into cubics and whatever other kind of functions they're called. And we just say polynomial because this is many terms, okay? Many terms in your polynomials. You could have many terms, you don't have to have many terms.
So would that be called a trinomial?
No, a trinomial would have 3 terms in it. That's what your quadratic like this would be a trinomial if I did not have that. But a trinomial is any time you have 3 terms added together. Okay, they don't have to be in the form of a polynomial function at all. Okay, so just out of curiosity here, you guys, you see how this is a 1 on your exponent? That means that this 3 right here is your a sub 1. It's the coefficient of the x to the first term. What would your a sub 3 be?
The -2.
You know what? I think I just said it wrong. No, I didn't. A sub 1 is 3. So a sub 3 is what? -2 is good.
Oh.
So the subscript matches the what? Exponent, yeah. The subscript matches the exponent. Alright, so this is the coefficient of the x cubed term, so this is a sub 3. This is the coefficient of the x squared term, so the 5 would be a sub 2. Alright, so that's about it for that idea. I want to hit a little bit of terminology with you. I want you to know that your n, and I think actually the definition actually says, polynomial function, the function f of x equals all that stuff is called a polynomial function of x with degree n. That's your definition of polynomial function. You'll find that in your book on page 136, if you care. Which, since it's here now, while I go looking it up, you're going to get the same thing. What do you think the domain of any polynomial function is?
All real numbers.
Yeah, it is definitely all real numbers. How come?
Because it keeps going.
It keeps going forever and ever and ever. Okay, from negative infinity to positive infinity. If you recall at the beginning of the year, we had restrictions on the domain of a function. And the only 2 things that make restrictions on the domain of a function are when there's a 0 in the denominator. I have no denominators, no x's in any denominator, right? And when there's a negative in the radicand of an even root, and I have no roots. So I have neither one of those things to pay attention to. I don't have any roots, so I'm not going to have any exemptions because of any even roots. And I don't have any denominators with any variables down there, so I don't have to worry about that. Now these things, this coefficient here, this could be a fraction. But even if it is a fraction like 2/3, I won't have any x's in the denominator, so I don't have to worry about any of that. Alright, the n, let me see, the domain is all real numbers. The n is called the degree. So if your polynomial function is in this format, then the highest exponent you see is considered the degree of that polynomial function. Just like you knew that x cubed was a cubic and the x squared was a quadratic, the highest exponent determines the degree of the polynomial function. A sub n is called the leading coefficient. Is that logical?
Yes.
It's definitely a coefficient of the first term, and if it's the coefficient of the first term, it's the leading coefficient. So we're going to call that LC, but we're not going to say LC. As we write LC, we will say
Leading coefficient.
coefficient. Excellent. Okay. And what do you suppose A sub 0 is? I have a name for that also. It's the thing way on the end. And it has no x.
Constant.
Yes, good, it's the constant term. Alright, so a sub 0 is the constant term at the end. Am I missing anything I want to say here? Yeah, I want to say that a sub n right here, whoops, a sub n is not allowed to equal 0. Not allowed to equal 0, and it won't equal 0, so I think we're being a little bit redundant, but let's say, for instance, my function were something like this, 0x to the 4th plus 5x squared minus 9. What is the degree of that polynomial function?
4.
People want to say 4, and it's not really fair, right? Because couldn't I put a 0 in front of any x with a different exponent? So isn't this really like gone? So the highest degree on that x that matters is that 2. You hear me?
Yeah.
So the leading coefficient can't be 0 because it's like making up a fake term that doesn't belong in the whole problem. Okay. So the leading coefficient's going to be something other than 0. Alrighty. We already said that n has to be a non-negative integer. Okay? So the degree, and what I say is going to be a, although I think it can be a 0. Yeah.
Keep it good, 'cause I got it.
So I'll just leave that alone. Okay? That means that I can have a polynomial function that's just a single number on the end, like a constant function, like y equals 2 or something like that. Alright, so this is all there is to this. Let me just give you one function, and let me ask you a bunch of stuff about it, a bunch of things with the terminology here. So I'm going to say like negative 3x to the 7th plus 5x to the 4th minus 8x plus 9. What is the degree of this polynomial function?
7.
N is 7.
Yeah,
Very good. What is the leading coefficient of this polynomial function?
Sheesh.
Negative 3.
Oh, shoot.
What is a sub,
The constant.
well, let's get tricky here. What's a sub 4?
5.
5.
What the?
Okay? A sub 4 represents the coefficient on the x to the 4th term. What is a sub 1?
Negative 8.
Negative 8, it's right here. Okay. And what is a sub 0? 9. Where did I lose you? Don't look behind you, you know it's you.
8 to 4.
A to the 4th?
Yeah.
A sub 4?
8 sub 4.
So see how every subscript and every exponent match?
Yeah.
So every subscript and every exponent match. So if I want a sub 4, I have to find where there's an a sub 4 x to the 4th. So you scan the problem. Do you see the x to the 4th problem? Part of it? Okay. And you see the number outside of it? And that's a 5. Okay. So I'm glad you looked a little confused. I'm glad you entertained the question because I heard a few, oh, I get it now. All right. Questions, comments? They can be trickier than this though. Go ahead.
You know how you said something about placeholders at the beginning?
Yep.
So say if like it asked us what a sub 6 was, would that be
Uh-huh.
0? Okay.
Good job. Good job. Good job. Good job. All right. The only thing that can't be 0 is your that leading coefficient with the highest exponent there. I can have other zeros, especially if I'm missing terms. Yep.
So if we're ever asked, like, what is, like, for example, like, what does negative 3 represent? If somebody put a sub 0 and then another, a sub 7 and then another person put leading coefficient, like,
I would probably give either one of them. Because it's both. What you just said were both right, correct answers. So if I leave an open-ended question like that, then I would have to expect to be able to give credit for whatever correct answer is there. Okay. Questions, comments? Yeah.
So, a sub 6, I'm just wondering why that's equal to 0.
Huh? Good idea. I don't know if I have room or not. But wouldn't I have to write negative 3x to the 7th plus 0x to the 6th plus 0x to the 5th plus 5x zero x cubed plus
0x squared
zero x squared
minus 8x
minus eight x.
plus 9.
If I wanted to see each and every term from the beginning to the end, like I were doing a long division problem or something, then that coefficient that's attached to an exponent of a 6, right here, would have to be the 0. Good? Okay, this thing right here, this a sub n, meaning the leading coefficient not equaling 0, that doesn't mean the other ones can't equal 0. Okay, I'm gonna erase what's on the board. I have that was good. I have 4 things I want to talk to you about, 4 combinations of things, and they're very, very simple. What I don't want to have to do is repeat myself tomorrow, the next day, and so on. Alright, so pay attention to these notes. This is super important. It's super easy to do. I think it's easy to do, and you will too. Just keep it straight. Okay? 4 different things coming at you. I'm going to pay attention as to whether or not n, which is the degree of a polynomial function, is odd or even. And I'm going to pay attention to whether the leading coefficient is positive or negative. And then there's 4 combinations of things. I can have an odd degree polynomial function with a positive leading coefficient. That's one combination. I can have an odd polynomial function, or an odd degree polynomial function with a negative leading coefficient. That's another combination. Or I could have an even degree polynomial function with a positive leading coefficient. Or I could have what's left?
Even
With a
degree
negative.
Even with a negative, okay? Even degree, remember, these aren't even and odd functions, these are even degree, odd degree. So, let's go ahead and do that. I'm gonna wipe this board clean. There are 4 examples that are gonna go on the board. These are our rules. This allows us to have our narrative, which are our definitions and our words and our vocabulary that we're gonna use when we talk through the rules. And I think you'll see the rules are pretty simple, okay? Did I already tell you that's your home phone up there?
Yes.
Yes.
Okay, good job. Alrighty. So 4 possible combinations of, let's say, the leading coefficient about that being positive or negative, and what else?
The degree.
And I care about that being,
Odd even.
you're right, odd or even. I chose to write even or odd because I plan to do the even one first. So, first combination. What do I have? Leading coefficient.
Positive leading coefficient with the even degree.
Yep, so leading coefficient positive. Now I can write leading coefficient positive, or you might see me write leading coefficient greater than 0. Isn't that the same thing?
Yeah.
Mathematically, positive means greater than 0. Alright, and I want to know that the degree of the polynomial function is even. So you guys have to come up with a polynomial function for me. One that we've already studied is one of our basic common functions that has an even degree and a positive leading coefficient. Every one of you should be thinking of it. What is it? Y equals, there's only one of you? X squared, even degree, positive leading coefficient, y equals positive x squared.
I definitely do that.
Yep.
Y
I'm only
equals
thinking like,
positive x squared. That is the easiest even degree polynomial function we've done. Alright, so do you know what it looks like?
yes.
Yes, okay. I hope everybody knows that it has this U shape, goes right down through what?
0,
0,
0, 0. Okay, and keeps going, whatever, something like that. I don't know how that looks from your perspective. Is it okay? Okay. Every single polynomial function that has an even degree to it and has a positive leading coefficient will share the same basic trait that y equals x squared does. That means that every single one of these will start high and end high. the left, ends high on the right. Now mathematically, starts high means that as x approaches negative infinity, so as I go further and further and further to the left, this graph is going further and further and further up. So as x approaches negative infinity, y is approaching infinity. Y is approaching positive infinity. Y is approaching positive infinity. As x approaches negative infinity, y is approaching positive infinity. That means as x gets smaller, y gets bigger. Now what's happening over here? As x gets larger, so I'm going to say as x approaches infinity or positive infinity, as x approaches positive infinity, y approaches positive infinity also. Good job. Now what I'm going to be looking for from you guys is just a little quick sketch of the 4 quadrants. And I want you to indicate this whole business by putting an asterisk up in the top left corner and an asterisk up in the top right corner. I will be looking for that from your work. I want 2 little asterisks. Okay? This function should start high and end high. And so does every polynomial function with an even degree and a positive leading coefficient. Next combination. Leading coefficient is still positive. N is now what? N is now odd. Leading coefficient is positive, N is now odd. I need you to pick a function for me that we've studied. There's a couple of them. I don't care which one you pick, really. Give me an odd degree polynomial function with a
X
positive leading coefficient.
Y equals X cubed.
Y equals x cubed, or somebody might be thinking y equals
X.
x. Either one of those work. And they share the same trait that we're about to talk about. But I like the x cubed also because it has a little oomph to it. Okay? And besides, if I just write y equals x, a lot of people aren't going to think that that's an odd exponent. They should, because there's an understood 1 there. But it's just a lot nicer just to see the x cubed. And I like drawing it too, so it's fun. So the y equals x cubed function has a little what going on there? Little whoop whoop whoop. Just a whoop whoop. Okay. So it's got a little whoop whoop thing going on in there. There's y equals x cubed. Obviously this function is starting
Low. Ending high.
start low. Oh, there's no E on low. And end high. So when I say start low, what does that mean?
Negative infinity.
As x goes to negative infinity,
Negative.
y goes to negative infinity. So as x goes to negative infinity, comma, y goes to negative infinity also. What do I mean when I say n high?
When x goes to positive infinity, y goes to positive infinity.
Good job, guys.
Good job. As x goes to positive infinity, the y value also goes to positive infinity. Now you know what little asterisk I expect?
Over the top.
1 and 3.
1 and 3. Okay. Not smack in the middle of the quadrants, but over in the corner edges, okay? So far easy?
Yeah.
Okay. I bet you could finish your notes all by yourself. What's the next thing I'm gonna write?
Negative leading coefficient and even degree.
So leading coefficient is negative, and n is what?
Uneven.
N is even. Can you think of a function that does that? Y equals negative x squared, yeah. See, once you do these,